All right, so we're gonna get started, guys. What's good, everyone? This is Professor Peters with you guys today. Welcome to my live stream number 2. Today is January 18th, 2023, 6:30 p.m. Eastern Standard Time. So today, what we're gonna be talking about, guys, we're gonna be focusing on two topics. So we're gonna talk about how to write the equation of a line, and we're also gonna be talking about quadratics. So those are the two topics I'm gonna kind of stay in. So when we're talking about writing the equation of a line, guys, we're going to focus on two formulas. So the first formula is going to definitely be our slope formula, right? Y2 minus y1 divided by x2 minus x1. And what's going to be different with this video today, I did a lesson on this topic earlier, and I used the point slope formula to solve. However, today, what I'm going to focus on is on the second method that I showed you guys in that video. So we're not necessarily going to use this equation today. What we are going to focus on is using the slope formula. Slope intercept form, I should say. So y is equal to mx plus b. So we're going to use this equation and see if we can actually come up with an equation for the line, okay? And I showed you guys this new method on the video earlier this week. I'll make sure to link that below once we upload this one. All right, so guys, when we have 2 points, right, and they want us to write the equation of a line, understand, for us to write any equation of any line, we're going to have a slope, okay? So the first thing we're going to want to do is start off with our slope formula. By now, we know x is our first term, y is our second term, and we have to keep the formula consistent. So if I start in this parentheses, right, and this is my y2, that means that this has to be my x2. I can't say x2 is here and then y2 is here. That's when the issue arises, okay? So we're going to set this up, right? We have m is equal to 5 minus 1 divided by -2 minus 2. So once we start simplifying this, we're going to get 4 over -4, right? We simplify this fraction. So now we know that our slope, m, is equal to -1. So let's box this off, okay? So now we know m is equal to -1. Now the next thing we need to do is to now use this formula to see if we could come up with an equation. But while we're using it is because we want to specifically, right, specifically solve for b, because this is what we do not know, and we want to write the equation of a line. So now let's go through and let's plug some points in. So what I'm going to do, guys, I'm going to circle the point that I'm going to use, or should I say box it off. So we're going to use this one. So now what I'm going to do, I have my slope. I know the point that I'm going to use, and this is the formula. So now we say y. Well, when we look at this point, y is 5. So now I have 5 is equal to m, which is -1, let's put it in parentheses, times x, which is -2. And understand, guys, that we're trying to solve for b. So we don't know that. So we'll just write the remainder of the equation, which is just plus b. So now at this step, it turns into a regular equation. And I know you guys at this point of the year, you guys are excellent at solving equations. So we're going to have 5 is equal to +2 plus b. And now after I subtract 2, I'm going to get 3 is equal to b. So what does that mean, Mr. Peters? Well, let me tell you guys exactly what that means. That means that we now have our answer. And the answer is y is equal to -x, because, when it's -1, we don't have to put -1 in front of the x. It's the same thing. So we have -x plus b, which is just 3. So this is another method for us to solve when we're trying to write the equation of a line given 2 points. So what I'm going to do right now, I'm going to erase this middle section and we're going to use the point slope formula, right? To just make sure that this is actually the correct answer. So let's do some erasing, right? And we know that that point slope formula, let's write it down here, right? Y minus y1 is equal to, oh goodness, m and then parentheses x minus x1. All right. So this video wasn't necessarily focusing on this, but I just want to make sure for the students who are a little skeptical with it that they see for themselves that, hey, this will give us the same answer and the correct answer. So I'm going to use the same point again and I'm going to substitute. So y minus y1. Y1 is 5, right? So y minus 5 is equal to m, which is our slope, -1. And then in parentheses, we have x minus, and just remember that our x is also negative. And I spoke about that in our video earlier this week on this topic. Make sure you put your negative in parentheses so that you don't get it mixed up. So now we have y minus 5 is equal to negative x. Let's see, plus 2. Let's make sure we got this right. Yeah, I think that's right. Okay, here we go. This turns positive. That was my mistake, guys. So please make sure you double check your answers because I had a sign wrong. All right, so we're here now with this, and let's understand we want to get y by itself. So for us to get this y by itself, we're going to move this -5. So now after I add 5 on both sides, right, we clean this equation up, and all we have is y is equal to negative x. And then when we combine -2 and +5, we're going to get +3. And this is the magic right here, guys. So I'm focusing, like I said, on the slope-intercept formula. This is what we're going to use to solve today to get the equation of a line. And if you look at both my methods, we got the same exact answer. So now what I want to do, now that we know that this method does work, let's erase, right? Let's erase all this. And let's see if we would get the same exact answer if we use a different point. So what if we use the point 2, 1? So I write my equation, y is equal to mx plus b. And now we have a different point that we're using, but we want to know, are we going to get the same answer? So now I have 1 is equal to, remember m is -1 as well, -1 times x, which is 2, and then plus b. So now at this step, we have 1 is equal to -2 plus b. And as we solve for b, guys, by moving it over to the other side, or I should say moving 2 over to the other side, we're going to get the same y-intercept. Wrong number, guys. I'm sorry. So we're going to get the same y-intercept of 3. And just understand, guys, we already solved for the slope. So what I'm focusing on right now was just to make sure that no matter what point we use, right, whether it's this point or the second point, we're still going to get the same y-intercept, the same slope. And once we put it together, we're going to get the same equation. So understand you can use any of these 2 points as long as you plug it in and solve correctly. Okay? So what we're going to do now, I'm going to take a break and we're going to switch the problem now, right? We're going to use different numbers and we're going to go through this process one more time. All right, so this is problem number 2. All right, so problem number 2 now, they give us 2 new points. And the new points are going to be -5, 6. And then our second point is going to be 5, -2. So first things first, guys, like I said in the previous problem, what we want to start off with, right, is just making sure that we figure out the slope. So let's go through and do that, right? So now we have m is equal to 6 minus -2. Make sure that you guys remember when you subtract the negative, it's going to turn into an addition problem, right? And then now we have -5 minus 5, okay? So once we combine these, our slope is going to be +8 over -10. But if you guys remember, right, always try to reduce your fractions. Anytime you have a fraction, guys, just try to reduce it. Don't try to keep it like this because it's going to be problematic towards the end of the problem. So try to simplify, keep the numbers as small as possible, okay? So what I'm going to do, I'm going to divide both top and bottom by 2. So that's going to give me a -4 over 5. So let's just write that somewhere, right? We have slope m is equal to -4 over 5. And let's just box this off. All right. So we have our slope now, guys. And just remember, that's the first step. So now the second step, there's always two equations that we can use. We use the point slope formula, which is that y minus y1 is equal to m times x minus x1. But for this video, we're focusing only on this equation, right? And understand, guys, that we already have m. M is already figured out, right? We find our slope. Now what we want to do is substitute for y and x, right? After we pick a point, doesn't matter which one, and we're going to figure out what b is. So the point that I'm going to start off with, let's see, what point do we want to start off with? Let's see. Let's start off with this first one, okay? And I'm going to do both of them for the video purpose, so you guys see both. But let's start off with that first point. So it says y. So I know y is 6. So 6 is equal to m, which is -4 over 5. Let's just put this in parentheses, times x, which is -5, right? And we're going to add b to this, even though, remember, we're solving for b. So as I look at this problem here, the first thing that we want to do is focus right here. So we're multiplying fractions, right? So what I'm going to do is just make this 5 over 1, just so I won't get confused. And just understand that we're multiplying straight across. So we're going to get 6 is equal to +20 over 5 plus b. And at this step right here, guys, let's simplify 20 by 5. So we're going to have 6 is equal to 4 plus b. We're going to now combine our like terms. So I'm going to subtract 4 from itself and subtract 4 from the other side. And once I do that, we're going to get b is equal to 6 minus 4, which is 2. So what does this mean now? Hey, we have all the information that we need to combine this problem together. So now I know y, right, that standard, is equal to my slope, m, which is -4 over 5, right, x. So just remember, when we write the equation, y and x are standard, meaning they're always going to be there. So when we write the equation of a line, it's always going to be y is equal to the slope times x, right? Then we're going to plus, add, or subtract the y-intercept depending on its sign. So since this is a +2, we're just going to put +2 at the end. So once we solve and we get the equation for the line that passes through these 2 points, we would have y is equal to -4 over 5x plus 2. All right? So, and as we're going through this, guys, if you have any questions, we're going to try to look down at the comment section, see if we could address any issues for you guys, because we want to make sure that you guys get the most out of these live streams and you guys feel like you're getting the help that you need. All right? So I'm going to erase this. We're going to check the live chat real quick, and then we're going to come back and we're going to plug in the second point, and we're going to wrap up the first topic for our live stream tonight. Okay? So let's erase all this other stuff except for the equation, and let's see if we're going to get the same b in the same equation once we plug in the other point. So as I'm starting this off, guys, just remember that the slope isn't going to stay is going to stay the same, right? Even though I switch points, we already did the slope formula, right? We plug that in, we have slope. So now we're going to focus and substitute, right? Y is equal to mx plus b. So now y is -2. M is the same, -4/5. X has changed now. X is +5. And then the rest of the equation is just plus b. So like I said in the previous problem, I'm going to put 5/1, okay? And what happens is once we start simplifying, meaning I've multiplied straight across, I'm going to get -20/5 plus b, right? So we're on the same track. So at this step here, guys, before we can combine 20/5 and 2, let's change this into a whole number. So now we have -2 is equal to -4 plus b. We just brought b down. And just like our last problem, to figure out what b is, that means we have to get it absolutely by itself, okay? So when I add 4 on both sides, we're going to get the same thing. 2 is equal to b. So once I start putting all this information back together, guys, right? Y is equal to our slope, 4/5x, plus 2, right? So this would definitely be our answer. This is the right answer. And like I said, we're going to stop here with writing the equation of a line. There was a previous video earlier in our live. Please make sure you guys check that out, okay? All right. So no comments in the chat section, no problem. But what we're going to do now, we're going to switch over to quadratics. All right, and I have a few different problems for you guys tonight, so hopefully you guys enjoy. All right, so when we look at quadratics tonight, they give us a problem, and let's actually write this problem out. So let's write this out. All right. So we wrote the problem out. Now let's see if we can draw a nice diagram, right? And see what's going on with this problem. And yes, I forgot my ruler today, so we're gonna use the eraser to draw a nice square. So, oh, sorry. All right, so they tell us, given the diagram below, find the value of x if the area is 21 square meters. So you have 21 square meters, right? And in the diagram, they tell us that this length is x, and this length is x minus 4. So guys, I'm gonna be honest with you. When I was in algebra, these word problems were a little bit tricky for me. But let's just backtrack and let Professor Peters show you guys what we're supposed to do. So what are we talking about in this problem, right? In this problem, they specifically asked us about area. And if I'm not mistaken, area is always the length times the width, and that is equal to your area, right? So it's this is basically a square, rectangle, whatever you want to say. But we know one side is length, one side is going to be the width, and it should be equal to 21 square meters. So, Mr. Peters, what does that mean? Let's follow the formula. So x, right, length times width. So let's put in parentheses x minus 4, right? Because we have to multiply x by both terms. This is going to be equal to 21. So that's step number one. We came up with an equation to represent the problem, right? So now we have length times width is equal to the area. So now we're kind of in the same ballpark. Now let's go through and see how do we actually solve. So my first step is going to be to distribute. And we're only multiplying this outside term by what is inside the parentheses. Anything outside the parentheses, we're not going to distribute x with. So now, once we distribute, we're going to have x squared minus 4x is equal to 21. And the issue with this right here, guys, this is the real issue. This is the issue. A lot of students don't understand that they did the right step. This is the right step. So let's carry it up here up top so we can have a better view. So x squared minus 4x is equal to 21. So we're talking about quadratics, guys. So what's going to happen is we're going to have to move this 21 on the other side by subtracting it because it's positive. So once I do that step, I have x squared minus 4x minus 21 is now equal to 0, right? Because our quadratic equations are going to be equal to 0, or we're going to set it equal to 0, I should say. So now we're in business, right? Now we're talking about a trinomial. Now let's factor. And if you guys don't remember factoring, we're looking for two factors, two numbers that when we multiply, it's going to give us a negative 21. And then when we add, it'll give us a positive 4. So because both of us, me and you, are good at timetables, I'm not even going to go through that. We should know that it's going to be x minus 7, x plus 3, and this is equal to 0, right? So we're on a great track, and students will get to this step, but they forget the next key step. They will stop right here, and then Professor Peters has to come in, and I have to mark it wrong or partially wrong. So what we have to do here, guys, is set both of the factors equal to 0, then solve. So our first factor, right, when we set it equal to 0, we're going to get x is equal to 7. All right, so let's just box this off. Then we go to the next factor, and we have x plus 3 is equal to 0. So once we solve for x, right, by subtracting 3, we would get x is equal to negative 3. So now we got both of our factors. Are these the answers, though? What do you guys think? I hope y'all boys said no. You boys and girls said no. And I'm going to tell you why the answer is no, right? So first off, let's just talk about units, right? We know if we want square meters or meters squared, that means we have to multiply meters times meters, right? We're talking about dimension. We're talking about length, width, right? Measurements, right? So let's just put 7m and 3m. Now, if you pay, I don't want to say pay close attention. Now, if you peeped, if you recognize the issue, right? When have we ever had negative dimensions? Exactly. So x is equal to 7 meters, right? This would be our answer. Why? Because in our second factor, we're saying that x is equal to negative 3 meters. But y'all know we cannot have a negative measurement. So what happens is we have to negate this answer. We have to throw it out because we know that our measurement, our x, it can't be negative in this situation. So please make sure that you guys watch out for that trick. Man, I'm telling you so many times, students will go through and factor completely, but they forget, oh man, can't be negative. Like we're talking about length, we're talking about measurement. Peters told me about that. All right. So that's problem number one for our quadratics. Let's start erasing now, right? And we're gonna go into our second problem. So the second problem for tonight on quadratics is going to focus on how to factor in special situations. So I'm gonna show you what I mean. Okay. So just understand now, guys, we're talking about factoring. So they gave us the problem 4x to the second power minus 19x minus 5 is equal to 0. So typically, guys, when we have when we're factoring, And we have a quadratic where our lead term is greater than 1. We normally want to try to pull a greatest common factor, right? But when we look at all three of these terms, there's nothing that we could divide by so that this lead term could be 1. We can't. So what I'm going to introduce to you guys is the slip and slide method, okay? And I've done videos on this before. Please go into the algebra 1 section of our videos to find it. So we're going to multiply A and C, okay? So once I multiply 4 and 5, my new equation will be x squared minus 19x minus 20 is equal to 0. And why is this important? Because when we can't factor, right? When we can't factor, this is a method that helps us to make it a lot more easier. And I want to share it with you guys if you didn't catch it in our regular video. So now, when we look at this problem, this is so much more easier to factor compared to the original problem, right? And that's exactly what we want. So I'm going to put x in both of these. And I know my signs are more than likely going to have to be the opposite of each other, right? So we're going to have x plus 1, x minus 20, right? When we multiply, we'll get negative 20. And when we add negative 20 and positive 1, we're going to get negative 19. See, now that's not necessarily the challenging part. The challenging part with this method now is to go back and divide. We multiplied by 4. Now, after we find our factors, we're going to divide both the factors by that number, right, that we multiplied by. So now I'm going to go back and divide by 4. And this is how slip and slide works. If the numerator, if that top number cannot be divided by the bottom number and result in a whole number, you're going to take that denominator and put it in front of the x, okay? So what happens is we're going to have 4x plus 1 is equal to 0. And then in our second one, when we are able to divide, we're just going to simplify. X minus 5 is equal to 0. So I'm going to stay on this part first because it's faster and it's easier. I'm going to add 5 on both sides. So my first answer is x is equal to positive 5. All right? And now we're going to take our attention back to this, right? We set both of them equal to 0. So let's solve. So we're going to get 1 on the other side, right? Because the variable and our constant have to be on opposite sides of the equal sign, okay? And to finish this problem up, we are now going to divide by 4, and we have x is equal to negative 1 over 4, and x is equal to 5. So now we factored, and these should be the two answers that we get, okay? And like I said, guys, this is called a slip and slide method. I've definitely done a video on this before, so if you're interested in this topic, just go back into the Algebra 1 section of our videos, and you will definitely see it. I will try to tag that video or put it in the description of this video below. All right? All right, so our last video now, not last video, I'm sorry, our last problem now, we're going to try to graph a quadratic equation. So as I'm graphing, guys, just understand that my graph may not be the best because I'm freehanding it, but the x's and everything else will be correct. All right, so let's finish off this last problem for today. And like I said, guys, thank you so much for joining us on our live stream. Please make sure you check the description box. We left our email down there. So if there's any specific problems or questions you have that you want us to do on our live stream, our regular videos, let us know, and we'll definitely include them in our videos for you guys. All right, so let's see. Our last problem, they want us to graph y is equal to, oh, I'm sorry. Did I put y is equal to? Yeah, we did it. Y is equal to negative x squared minus 6x minus 5. So what we're going to do real quick, guys, let's just draw a little graph right here to the side, right? And next video, I'm gonna make sure that I have an a ruler. Thought I had my ruler, guys. I do not know where I put it today, but we're gonna make this work. All right. So first thing we want to notice, guys, is that this graph is 9 times out of 10 going to open down. All right. So let's just make sure we make that first observation. It's going to open down because it's negative. 2, for us to find a vertex, meaning where the graph is cut in half, we're going to use the formula x is equal to negative b over 2a. And for us to know what a, b, and c is, let's write the formula. Ax squared plus bx plus c. So understand that a is our first term, b is our middle term. So we don't see a number, right, for a. We should know that it's just -1. So I know a is -1, b is -6, and even though it doesn't ask us about c, we'll just put that as -5 as well. Yep. Hmm. And you know what's crazy? Hold on one second, guys. So I think this should be a plus sign in the middle. Yeah, I believe this should be a plus sign in the middle because it's not going to make sense. Yeah, no, I think this is the plus. Okay. All right, so let's see if we could go ahead now and solve. So the first thing we're going to do, guys, we want to factor this, right? So negative x squared. Mm, all right. Let's make sure we got this right. Dun, dun, dun. Hmm. All right, so the issue right now, guys, is that I believe I wrote this problem wrong. So just to save the video and time purpose, let's make sure that we just make that positive. I think I wrote that problem down wrong. Can't believe it, man. I was so excited for the lesson today, but we'll make sure that we make it up. All right. So let's see. We have x minus 1, x minus 5. When we add them, it gives us 6 when we multiply 5. Okay. All right. So like I said, guys, sometimes the teacher gets so excited. I really wanted to do one where we open down the parabola, but it's all fine. So back to this now. So we're factoring this trinomial right here, and these are the two factors that we're going to have, okay? So we multiply to get +5. When we add, we get -6. We're all good. So now what I'm going to do, we're going to set our factors equal to 0, right? So we know our first factor is going to give us x is equal to 1. So let's just go over here and let's put x is equal to 1. Okay? So we're gonna assume that this is 1. Then we go to our other side and we have x minus 5 is equal to 0. So we're gonna get, let's see, when we add, we're gonna get x is equal to 5. So here goes both of our zeros. This is the x-intercepts. This is where this parabola is going to cross through this graph. And like I said, guys, just showing you the process. Typically, I'd use graph paper, but for today's video, we're just going to freehand it, okay? So now we got the both of those x coordinate, the solutions to the graph, the zeros. So now what we're looking for is the vertex, right? The lowest point or highest point, basically, where it's going from increasing to decreasing or vice versa. So it tells us that we're going to do negative b, right? So the opposite of b. So let's write that down. X is equal to the opposite of b divided by 2 times 1. So now x is equal to positive 6 over 2. So we know x is equal to 3. So what we're going to do, we're going to go right here and we're just going to put a circle, right? I'm not going to fill it in because this is not the final vertex point. What happens now, right? After we use the vertex and we get what x is, we now have to take that x and plug it into the quadratic equation. Once we do that, we'll be able to get the y point for the vertex. So what I'm going to do here, let's just erase x is equal to 3, right? I'm going to put it right here. X is equal to 3. We already did the vertex, so we know x is equal to 3. So now we want to focus on what happens when I plug 3 in for x. So now we have y is equal to, and everywhere I see x, I'm going to put in 3. So we have 3 squared minus 6 times 3 plus 5. So y is equal to 9 minus 18 plus 5. All right. And if you guys remember order of operations, don't you add 18 and 5 first. Please make sure you guys subtract from left to right. All right, that's just a quick joke for you guys because after a while of doing it so often, you kind of forget when you move higher up in math because it's almost like it's just instinct wise, right? So we have y is equal to negative 9 plus 5. I got negative 9 from just doing this first operation. Now when I focus here, y is going to be equal to negative 4. So Peters, what in the world does this answer mean? We just finished off the coordinate, right? So when we think about a point on a graph, we have an x term, right? That's what we got from this formula. We got the x, and after I got my x, I plugged it in to figure out my y, right? So now we're saying at this point, 3, negative 4. So I put the point at 3. Now we're going to go down to negative 4. This is going to represent my vertex. And if you guys remember, when we're graphing quadratics, parabolas, those U graphs, we have to have at least 3 points. So what I'm going to do now, I'm going to draw in my U. And goodness, bear with me. It's probably not going to be all that pretty. We're going to draw in our U, and these are the 3 points that should be included. So this is what our graph should look like as a quick sketch, right? And we have both our zeros and our vertex down at the bottom. Let's just darken these up. All right. So this is how you guys will graph a quadratic equation. It's going to look like a U. And we're going to finish up here for tonight, guys. Thank you so much for watching and joining us tonight on our live stream number 2. We're not going to be back next Wednesday. Next Wednesday, we will take a break and we will be back the following Wednesday. I'll make sure to post that in the community tab. But thank you guys so much for joining me today. This is Professor Peters, and you guys are watching Algebra 1 with Mr. Peters. You guys have a great night. And as always, go Canes.